Today I'm going to talk to you about fermenting fuel provided by Kansas corn. Hi, I'm James Burk, science teacher at Trigo Community High School, lead teacher for Kansas corn. Today I'll be talking to you about fermenting fuel, a lab provided by Kansas corn stem. The purpose of this lab is to allow students to design and set up their own procedure for fermenting as much ethanol as quickly as possible. They'll use their design later in the distillation lab to produce ethanol for distillation. So in setting up our samples, we're going to weigh out, turn on the balance here. You can do it by volume, there it goes, or by mass. You just want to make sure you have the same amount of corn grind in each one. So it's about 2.5 grams. In the procedure it says 1 gram, but it's not. You don't have to be really rigid. As long as each sample is going to be about the same. I already weighed out the other samples. And again, you can just do a teaspoon of corn grind in each sample. I have my students set up their samples, boil their samples, and design their experiments on one day. And then the next day they can run their experiment, collect results, and kind of make sense of what happened. So just put corn grind in each of the test tubes. I already have the test tube holders on them. Then we'll add some distilled water and boil them for 10 minutes to get the starch ready to go for the enzymes. Okay, again, the amount of water isn't super technical. I think in the procedure I wrote 5 milliliters. You just want to make sure you have about the same amount. So the fastest thing to have my students do is just to measure to, say, the top of the test tube rack that they're using right here. So they're not spending a lot of time measuring things, but they get the same amount, so they control that variable, so they're dealing with the same samples as much as they can be. A few air bubbles in this one. Grab a stirring rod, and they can mix their samples up, we don't have anything different between these, so you don't have to spend a lot of time rinsing off between samples. Okay. And you set up a water bath like this. I use a 1 liter beaker. You could use a smaller beaker in this scenario. You can do about 10 samples in each one. Set those. And the water bath keeps them from scorching and allows you to heat them all evenly. So we'll boil those for about 10 minutes. During that time, we'll mix up some enzymes. If you're using the dry enzymes that we've used in the past, I usually just use a 1%. So 1 gram of enzyme make 100 milliliters of enzyme solution. So I just add 1 gram of enzyme to the container and then fill it to 100 milliliters. So I'll go with the glucoamylase first. And on your pipettes, if you're using these pipettes, I usually just have the students label them with an A, so we don't have to get a new one out each time. They can. And the wet enzymes, that's what we're using now, need to be about a 2% solution. So we'll use 2 milliliters. This is the amylase. Let's see, I'll add it to a graduated cylinder first. And then dilute that to 100 milliliters. And these are the enzymes that they use at the ethanol plants. and very similar to the powdered enzymes, but they do last a little bit longer. So this is the amylase solution. Same thing with the glucoamylase. Again, just 2 milliliters of concentrated enzyme. And dilute that to 100 milliliters of solution. You want to make sure your enzymes aren't too dilute. We followed some of the procedures initially, and it takes a lot longer for you to get results. So if anything, you want to have too concentrated a solution so you don't not waiting for your yeast to get active. So there's our 2 enzyme solutions. Let's see, we also have some buffer solution. And what we're going to do in this lab is, instead of being able to just measure ethanol directly, which would take an ethanol probe or something high-tech like that, we're going to look at the carbon dioxide being produced and capture that. Similar to what's happening in the fermentation in a bag, but we're going to do it a little more quantifiable. Because every ethanol molecule that's produced, there's also a carbon dioxide molecule that's going to be produced. So if you can quantify your carbon dioxide, you're getting a pretty good estimate of how much ethanol is being produced. The enzymes, the glucoamylase I mentioned, snips glucose molecules that the yeast are going to use off of the starch individually. The amylase is a little less specific. It's going to release 3 or 4 glucose chains that the yeast can chew on, but it's a little more of a complex carbohydrate. Went through the preparing samples. So we have our samples boiled now. So we'll grab them. If you're storing them overnight, you can just put a stopper in them. It can be a cork or a stopper. Try to get these in order here. Okay, store them overnight. I have my students just fill out a table, basically, of what they want to put in, which enzymes they want to use, and that's the experiment we're going to do today, is using all the same yeast, because there are a lot of different characteristics of yeast, and I'll have students test that. Sometimes they blend the yeast, different temperatures. There's a lot of different things that you can use for variables in this, but we'll just go through with the different enzymes right now. So in test tube 1, so we'll open up all of our test tubes. If you look at the PowerPoint here, it shows the amylase we're going to add. We're going to add amylase, 2 milliliters of amylase to test tubes 1, 3, and 5. And this is what the students would be doing on their own, or designing on their own. A lot of times I'll have them go through one that I've designed first and then let them kind of expand from there. They get really excited about changing different. So I'm just going to put 6 milliliters in here. So 1. I'm just dropping it down 2 milliliters each time. So 1, 3, and 5 get amylase. And then 1, 4, and 5 get glucoamylase. Switch out my pull up 6 milliliters, so I don't have to keep coming back to it. So we got 1, 0.5. Then we'll add some pH buffer, because the yeast typically like certain pHs that they seem to function better at. And this is a pH 5 buffer. And in this case, each sample is going to get 2 milliliters of pH buffer. So I'll need 10 total. And you can run samples without pH buffer in them, see if it does anything. There's a lot of different variables, and it's kind of what they do at the ethanol plant. They have a lot more technical equipment for testing this stuff, but they're constantly changing variables, trying to make a more efficient process for producing ethanol. So we get to this point, we don't want to mix much between our samples, but we do need to stir these samples up a little bit, get the enzymes mixed up here. So, and especially if you let them sit overnight, the corn grind in the bottom starts turning to almost like oatmeal that sat overnight. It takes a little bit of stirring to get it mixed up. And be careful not to break a stirring rod or anything. But we don't have any yeast in there yet, so in order to not mix up enzymes, you can wipe it off or rinse it off between each. If you have enough stirring rods, you can just use a new one for each. Another thing I have my students do the day before when they're boiling their corn and getting everything set up is weighing out the types of yeast they're going to use. So if they're using different types of yeast, they mark these little 15 milliliter centrifuge tubes and weigh out their yeast, so they don't have to do that the next day, because my class periods are only 50 minutes long, so I want to get in, get the experiment started so they can collect data for as long as possible during the lab period. All right, I won't worry about stirring those too great. Okay. Then we'll dump in the yeast. Like I said, all of these are the same type of yeast, the Red Star Distiller's Active Dry Yeast, and they're all 1 gram. Again, you can do that on volume if you want to, just again, consistent amount of yeast. This would be on the day that they're running their experiment. They would add the enzymes and the yeast. And then we can add a little bit of water to them. We're going to stir these again. And we had a lot more yeast per amount of corn in this step because we're trying to get the lab done in probably 30-40 minutes, where with the distillation, you're going to let it run overnight, at least 24 hours for the Now, when this starts to ferment, the yeast they'll produce quite a bit of bubbles. Some of the bubbles might end up in the tubing. That's not a huge problem, just makes it a little more cleanup. But I try to rinse the yeast down on the side and leave about 1 inch below the top of the test tube. I'll try to get them all to the same level. you don't want to fill them all the way up, or you'll definitely push a lot of yeast and solution over into your container. So we get to this point, we can set our manifold. This has little openings on this side. You want those facing the yeast samples or the samples you're fermenting. You just put underneath the water, tap it a few times, get as many bubbles out as you can, and just tip it up like that. If you're having trouble getting the bubbles out of the top, you might need more water. So this is our, should be probably number 2 rubber stopper with some tubing in it. And put those in. You don't want it to leak, but you don't want to force it in too far. And then that just goes inside the hole so it catches any bubbles that are coming out of our fermentation tubes here. One of the variables that one of my students came up with, because he'd been around his mom baking bread and he knew she warmed up the yeast. So one of the things we do is a warm water bath for our samples, and you can use a sous vide and a water bath for that. So somewhere around 37 to 40 degrees Celsius is usually a pretty good spot, but you can let students test that. Just set your samples down in the warm water. I mean, you might have to set a mass on that to keep it in the water. Another hint here is when these start filling up with water, they tend to float a little bit, so you might want to run some masking tape or scotch tape across the top just to keep them from moving around a lot. You'll see in the time lapse I had some floating a bit. Okay, so this is pretty much what you should look like right now. Right now we've got the test tube rack and the samples in a water bath. You don't have to do that step. You can run them at room temperature. It just takes a little bit longer. And students at this point are going to be watching for bubbles being produced in these centrifuge tubes and watching as the different amounts of carbon dioxide are produced. The more carbon dioxide produced, again, the more ethanol is being produced in that tube. So it's just a real quick, easy way to quantify how much ethanol they're making. This is a time lapse of some of my students. You can see the water levels dropping here. So I have them record every 5 minutes on a data table and graph, and then we use a whiteboard, and they go ahead and fill their graph out on the whiteboard too. So when we get done, each group of students shares out their results and what had worked best. We can compare directly if somebody did the same thing at a different temperature, and we can see which temperature produced the most ethanol. Here's what the graphs and the data table looks like. So again, every 5-10 minutes, whatever you want to put in here, depending on how long your time period is, the students record and graph their data. And we can look at this one and see that the blue test tube number 4 was the best. So we can go back and look at what we had in that test tube, and that one had 2 milliliters of glucoamylase. Didn't have any amylase, so for some reason that one did better. So students can use this to develop and engineer a procedure for the larger distillation setup. I usually give them a cost analysis sheet, which comes directly from what I could buy them from on Amazon at the time. So different types of yeast you can use. Fleischmann's Rapid Rise, it's like 41 cents per gallon. The Red Star Distiller's Active Dry Yeast, or per gram, say gallon, 27 cents per gram, and then the ethanol red that comes from the ethanol plants is 25 cents per gram. So I usually limit them to about 5 grams of yeast, because obviously if they dump in massive amounts, it just costs me a lot and I run out, but kind of set some parameters on there. Costs for the different enzymes and buffer solutions, so they get a kind of a cost-benefit analysis, and they aren't just dumping in as much as they possibly can. They have to think through trying to produce the most ethanol for the least amount of money.